Source of Science Physics, and I'm Mrs. Bolden. And today, in part 3 of my wave series, we're going to talk about wave motion. So, the energy transferred by a wave from a vibrating source to a receiver is carried by the disturbance in the medium, not the actual particles of matter. So, this is kind of a weird concept. You think when you're looking at the ocean and a wave is coming toward you, the little particles of water that are in the wave are actually moving toward you, but it's not. It's the energy that's transferred by the wave, not the actual particles. Okay. So most information gets to us in some form of a wave. Some examples of this would be sound. Whenever I'm saying, hello, I'm talking to you, the lovely sound that comes out, and I use lovely kind of sarcastically there, sound that comes out of my mouth. It is a disturbance in the air between my mouth and your ear that is responsible for the sound. Light is also something that also gets to us from in the form of a wave. It's an electromagnetic wave, and when we get to chapter 27, we'll talk more about that. Radio waves, if anybody still listens to radio comes to us in the form of a wave, and we talked about AM and FM radio. TV, if you don't have cable TV or use satellite TV, or even satellite TV comes to us in the form of a wave. But if you don't have, if you don't use the internet, if you just have like the antenna on the side of your head, why would you have it on the side of your head? You wouldn't. If you have an antenna on your roof and get your TV that way, that comes in the form of a wave. So it's the energy that's transferred by the wave from the vibrating source to the receiver. So and I'll use radio waves as an example. Skowhegan a while ago used to have a radio station right here in town. It used to be up on the middle road, just outside of town. And they had this big, tall antenna there, and there was something that vibrated in the antenna, which vibrated the air around it, and that eventually got to the different radios that were picking it up. And if you tuned your radio to a particular frequency, then you could hear what is being transmitted, the energy that's being transferred by the wave. So think about a very simple wave produced when one end of a horizontally stretched spring is shaken up and down, and I think I have a picture of that. The disturbance moves to the wall, but not the parts of the string or the spring itself. So when you have a string and you're shaking it up and down, the end of the string that's touching your hand doesn't actually move toward the wall. It's the energy that moves toward the wall, not the individual particles itself. So here we are, we're shaking the string. The part that you're holding right here is not moving toward the wall, it's staying in your hand, but it's the energy that gets transmitted along that string and eventually ends up in the wall. Okay. Another example is you drop a stone into a quiet pond or a very large mud puddle. You'll produce a wave that moves out from the center in an expanding circle. And probably everybody has done that. It's the disturbance that moves, not the water molecules themselves. So right here, when you drop something in the water, it makes this big wave, but the particles that moved here initially are not the particles that are out here causing the wave to carry along. What happens is the particles here disturb the particles next to them, and so forth and so on, all the way out to the edge of the wave. When someone speaks across the room and says, hello, the sound wave is a disturbance in the air that travels across the room. It's not actually the molecules that come from my voice box, the vibrations produced in the air by my voice box, that come across the room. It's the the disturbance that comes and knocks on your eardrum and says, "Oh my God, she's doing that again." So the air molecules do not move along. In the air, it's the medium through which the air is the medium which the wave energy travels, not the actual particles of air move from my voice box, my larynx, to your ear. Thank goodness, huh? Here's a note that nota bene, and you know that means pay attention. The matter doesn't move to a new place, but the matter transmits the energy to a new place. So if you think about an ocean, not an ocean wave, if you throw a rock into a pond, the rock disturbs the water in one place, which in turn disturbs the water next to it, which in turn disturbs the water next to it, and so forth and so on, until it finally gets to shore. Okay, that's it for this time. Thanks for joining me. Have a great day.